this question, we're told an object is moving to the right with speed vi. So our initial speed, there's a force exerted on it. Is the object's direction of motion changing and the kinetic energy decreasing? Let's start with the kinetic energy decreasing. EK is 1/2 mv squared, and it's an object. So we have every reason to believe that, and there's no mention of the mass changing, so the mass is going to be the same. So for the kinetic energy to decrease, the speed must decrease. So our first approach here is just to determine which of them would cause the speed to decrease. If we look at choice A, we have a velocity. No component of that force is in the direction of the velocity. So it is neither going to add to the velocity to the right, nor will it detract from the velocity to the right. But this is an unbalanced force. Then we would expect that force to cause the object to accelerate in the direction upward, in this direction. So we'd actually expect then it to start moving off in that direction, which would bring about a greater velocity. So in this case, the velocity would increase. So the kinetic energy would increase. So this is the opposite answer, it turns out. In choice B, what we can see is the force is opposing the velocity. So clearly, if there is a force acting in this direction, it will cause it to slow down. So V will decrease and kinetic energy will decrease. So this could be a possibility. Choice C, we observe that there is a force component in the direction of motion and a force component in this sideways direction. So not only is the force in the same direction of the velocity, this would cause the velocity to increase, but there's now a force component causing it to accelerate in the y direction, so further increasing the velocity. So we have a velocity increase, which means a kinetic energy increase, and that cannot possibly be a choice. Choice D, we can see that there is a component in this direction that opposes the motion and a component off to the side. So we do see there is a component of the force that will cause the velocity to slow down in the x direction. And there's this, oddly, there is this force in the y direction is going to cause some acceleration in the y. So we know we have a definite decrease in velocity x. We have an increase in velocity y. So if we consider just the velocity x, the velocity would decrease. Velocity y increase. We have two things going on here. Now let's look at the second part. We've narrowed it down to two choices, B and D. Let's look at the direction of motion. Clearly in choice B, there's not going to be any change in direction. It's just going to continue along this line and come to a stop. So it can't be choice B. And what is curious here is this choice D, because there is an acceleration in the y direction, there is an increase in speed. So ultimately, what it comes down to is what's the component of these? If the force is greater in the x direction, meaning if it's less than 45, if the x component is larger than the y component, then it will bring about a greater change in the x than there is an increase in y. But notice we don't really have to get into that. We narrow it down to B and D, and we can see that B can't possibly be bringing about a change in direction of motion.